All right, well, we'll go ahead and get started. I want to say thank you to everyone for making time to come, whether it's virtually or in person, to hear this afternoon's talk. And I will be speaking on water, nutrient, and knowledge transport in urban forests. And what all I mean by that. I will say before jumping in that this is my first talk on my feet since 2019, 2020. So this is interesting to be in person again, standing up. But I'm excited to be here and excited to share with you all a little bit more about the research program, as well as the extension work and the teaching that I've been doing since I started this position about 3 years ago. So I want to start off by sharing that my position here at MSU is supported through a PERM agreement, PERM standing for the Partnership for Ecosystem Research and Management. The PERM agreement is more than 25 years old now, and it's an established relationship between MSU's College of Ag and Natural Resources and Michigan's Department of Natural Resources. And between the two, the agreement facilitates the support of faculty members to conduct research in the broad field of natural resources that will help advance the way that we understand the way natural resources function here in the state of Michigan, as well as advance the way we manage them. And so in having a position that is supported through a PERM agreement, when I started here at MSU, I had to really begin to take some time to think about what that meant for the state of Michigan, which was completely new to me coming from the East Coast. And then what I wanted it to mean for me as I was establishing myself in this role. And so as I took time to think about what the PERM agreement is, its history, and the forward vision for my role being supported through PERM, I started to think about what I wanted that to look like for me in this role. And in that time of reflection, I came to the realization that if this role was going to be one that I could embody and potentially be successful in, I need to model it around the PERM model. And that is really establishing partnerships that were going to result in the advancement of urban forestry in the state of Michigan in various levels and potentially beyond. And so some of the partnerships that I mapped out mentally and began to shape my program around forming were those that exist among scholars in urban forestry, natural resources, and urban and regional planning. I also wanted to seek out and build partnerships between scholars and practitioners in this field of urban and community forestry, then between scholars and diverse stakeholders across the state. And then finally, I wanted to establish partnerships within communities of practice, both here in Michigan and in the broader urban and community forestry community, statewide and beyond. Yeah. Mm-hmm. Oh, thank you for bringing that up. I think I may have missed that. Okay, can you see him now? Awesome, thank you. Yep, all right, let me go ahead and make that big. Okay, and I will admit that happened to me countless times in class this semester, or this past semester, so happy to see I'm keeping the tradition strong. But that being said, I'll take a quick second just to flash back for those who weren't able to see the screen. But I just shared that the program that I have begun to develop here is all based on this notion of partnerships that are going to help advance the practice and the study of urban and community forestry here in Michigan and beyond. And so taking the time to reflect on that also put me in a position to think about what were the pillars that I wanted to establish my research program upon. And there are three main pillars that really govern the work that I do here and plan to continue doing for the foreseeable future. That first pillar is really rooted directly to my research, which is really, no pun intended, rooted in this desire to understand the relationship between physical tree traits and the ability of urban trees to provide ecosystem services that residential and other stakeholders may rely on in our cities and municipalities around the state. In addition to making sure that we're able to continue to do this research that advances our knowledge in this area, I'm also very driven by the desire to make sure that the research doesn't stop in the academy or in the journals that we publish in, but rather that it is translatable to practice. And so I've also put significant work into understanding how we can better ensure that this research can be applied to the successful forest management of our urban forests. And beyond that, I've also built my program upon a pillar that is centered on capacity building and making sure that statewide there is a continuously increasing capacity for the successful care and management of our urban trees. Yep. Oh yeah, thank you. Okay. So that being said, what we'll take the time to review today is a couple of studies that I've been working on and projects that I'm working through within my lab and with broader bodies of collaborators. I'll take a little bit to talk about some of the classroom instruction I've done in urban and community forestry over the past 3 years. We'll look at some of the capacity building work, today focusing mainly on the workforce development programming I've been a part of developing. And then we'll take a few minutes at the end to look at some of the future work that I intend to engage in. So we'll talk about two research areas that have been central to my program here. And the first is really linked to that establishing or understanding those connections between physical tree traits and the cycling of water and nutrients in urban forests. Now, as an ode to Prince, there is a little bit of purple rain in this figure here, but the bigger picture that we're looking at is what happens when it rains on an urban tree. What are the potential fates of that precipitation? And externally speaking, there are 3 potential fates that we tend to look at in my research group. They include interception of precipitation, which is that precipitation that's captured by the canopy and eventually returned to the atmosphere via evaporation. And then there's the precipitation that will make its way through to the forest floor via throughfall, which may pass through gaps in the canopy or be released from canopy surfaces, or stem flow, which is that precipitation that will traverse down the trunk of a tree and make its way to the base that way. Stem flow tends to be more of a localized phenomena with the concentrations most maximum, if you will, at the base of the tree, whereas throughfall may tend to be, or does tend to be more spatially diffuse. So understanding what those 3 potential fates are puts us in a position to understand how urban trees can ultimately provide this one ecosystem service that they're often valued for, and that is contributing to local stormwater mitigation efforts. And so what the work that we do in my lab looks at these relationships by taking the time to study what's happening pattern-wise in terms of precipitation falling outside of the canopy, what's being intercepted by the canopy, and then what's passing through via throughfall and stem flow. And by taking in situ measurements of these different metrics, if you will, we're in a position to start understanding how rainfall is distributed by the canopy and what that means for scaling up and understanding those relationships between tree traits and stormwater mitigation. So when we talk about the physical characteristics of the canopy that do have an impact on this flux of water and nutrients through the canopy, there are many different directions that one can go in. For the sake of time today, I'll focus on 2 that are important for the work that we do in my lab. And one of the relationships that we look at is that between foliar tree traits and interception, and what that means for throughfall flux within our individual trees and our urban canopy more broadly. And one of the physical characteristics or structural characteristics of trees that will have an impact on your throughfall is leaf area. And essentially, we notice that there are some pretty clearly definable relationships between leaf area and interception and throughfall production. And those relationships are can essentially be boiled down to the higher leaf area you have, the higher interception capacity you have, the lower stem flow throughfall you're gonna see, and ultimately that higher LAI is gonna be linked to greater interception capacity and greater stormwater mitigation from your canopy. On the flip side, when you have decreasing LAI, you have decreasing surface area upon which precipitation can be captured, and ultimately that tree may be less effective at capturing precipitation, intercepting it, and contributing to stormwater management goals. Now, there are also some very interesting properties of bark that will also influence water capture by the canopy or by a tree. And again, you can spend a whole career studying that, part of what I intend to do. But some of the really simple relationships that we've developed an understanding of is that between bark roughness and bark water storage capacity. And essentially, what we've noticed is that smoother bark tends to be very effective at transporting precipitation to the base of the tree. And using some of the terminology that we learned earlier, the smoother the bark, oftentimes the higher the stem flow yield. And that higher stem flow yield essentially represents less water being stored by the canopy. And so when you've got these trees that have smoother bark, it's likely that they may not be as ideal in reaching these stormwater mitigation goals by the canopy. On the flip side, bark that tends to be rougher can be linked to having higher absorption capacity, or at least be more effective at retarding the flow of stem flow, and therefore potentially contributing to a higher capacity for stormwater mitigation by your canopy. Beyond the bark, canopy structure can also have an influence on water flow, water funneling to the stem and subsequent storage or lack thereof. And so higher branch inclination angles tend to be really effective with higher funneling by your trees, whereas your lower branch inclination angles do not, and as a result, can facilitate capturing precip in the canopy. Now, moving beyond these basic principles, we use various metrics to be able to quantify these relationships. And two of the metrics that are used in my research and in that of my students are the funneling ratio, and that is used to understand the hydrologic fluxes that occur with urban trees, specifically via stem flow. And what the funneling ratio tells us is how much more or less precipitation is funneled to the base of a tree because that tree is there. In other words, if that tree was not there, would you have more or less precip being funneled to the stem? Higher funneling ratio values, which are those that are greater than 1, indicate that that tree has some degree of efficient funneling and therefore is very productive at transporting water to the base. On the flip side, lower funneling ratios, especially those with a mean value less than 1, are very effective at absorbing precip or preventing it from reaching the base of the tree. So those values are very helpful in putting us in a position to determine how effective a tree is at capturing water or funneling it. And on the flip side, we also take time to look at some of the hydrochemical properties of both through flow and stem flow. And you can do this in various ways by just simply accounting for the concentration of nutrients and pollutants within your through flow and stem flow samples. But that's only half good. That's almost like taking a selfie and seeing what's there in the moment. By using some of these metrics, including our flux-based enrichment ratios, which you see here on the right-hand side of the screen, it puts you in a position to understand not just how the chemical amplification occurs due to rainfall interacting with the canopy, but also how that flux of water through an effective funneling tree will relate to a flux of nutrients being carried to the base. And understanding this flux of nutrients and water puts us in a position to also think about what type of biogeochemical activity may be facilitated by these trees and how that may change based on their physical traits and how effective they are at funneling water. So that is conceptually what the flux-based enrichment ratio and funneling ratios look like. Mathematically speaking, I just wanted to show this to give an idea of how they're calculated. And just to share again that flux-based enrichment ratio puts us in a position to understand how much more amplified, chemically speaking, a sample is after interacting with the tree. And the funneling ratio allows us to understand how much more water is being transported to the base because that water was funneled by the tree. So taking all that into account, the research that we do in our lab is ultimately working towards understanding these funneling capacities of different trees and how the funneling capacities relate to the amplification of precipitation chemistry and then ultimately transport of that amplified or magnified nutrient content to the soil. So to move forward in answering some of those questions, specifically how this changes from species to species based on the physical traits of our trees, we get out into the field and we do a lot of field-based sampling. Our sampling is event-based, with event being defined by rain events that produce more than about 5 millimeters of precipitation. That's what's needed on average to get you a sizable through-fall or stem flow sample. And once again, when we're out in the field, we have students who are collecting both through-fall and stem flow samples, and we always have an open rainfall sample to be able to facilitate our comparison of what's cycling through our forest versus what's cycling in the open. And again, we're moving towards this end goal of understanding how individual species may act based on various things, including their location, their traits, and what have you. So I'm going to very briefly show you some findings from a study that I had published earlier this year that looked at the enrichment ratios of white oak and northern red oak. And this is something that we can talk about in more detail later if that may be of interest. But I wanted to highlight just briefly the difference between these flux-based enrichment ratios for red oaks versus that for white oaks. And pay specific attention to the y-axis here. And you'll notice just how much you're getting an amplified effect, if you will, for the red oak versus the white oak. Remember now, our enrichment ratio is tied to both the flux of the precipitation and its chemical enrichment based on the interaction with the canopy. And what we see here is that our red oaks have significantly higher enrichment ratios for potassium. You'll see it holds steady for manganese, looking again at that y-axis, and for sulfur, when we compare these findings to that of our white oak. And this is important because it lets us know that first and foremost on the surface, different species have physical traits, right? What I should have mentioned is that between our red oak and our white oak, comparatively speaking, our white oak has a rougher bark surface than does our red oak. And that rougher bark surface facilitates a longer residence time of precipitation with that bark, which on the surface would allow you to think, oh, well, longer residence time, maybe greater potential for canopy exchange processes. Wouldn't the concentration of our stem flow be higher for red oak? The answer is yes, but the flux-based enrichment ratio doesn't just look at the concentration, which again is like that selfie. Instead, it looks at the total flux of precip and the total flux of chemically amplified precip to the soil. And what we found is that because our red oak has a smoother bark, that flux of chemically amplified precip tends to be significantly higher consistently for red oaks. And this puts us in a position to really begin to think about, again, physical tree traits. I was just talking to a colleague last night who said she loves going to Central Park, doesn't care much about the trees, she just walks past them. But studies like this put us in a position, even as those who do care about the trees, to continuously be mindful of the fact that the physical traits are going to vary species to species, and that is going to have an impact on how these trees interact with precipitation, and ultimately what that means for the physical storage of that precip and the chemical amplification of that, which can have managerial impacts, which we'll get into in a minute. So that's some of the work that's been published. Moving forward with the work that my students are working on and the work that I foresee building on in the future, with the study that I shared, that was looking at 2 species, right? And we all know that our urban forests are very biologically diverse. We've got significant variation in the species that are present there. And we need to be building on our knowledge of the various tree species that are often planted in our forests, our urban forests. And so moving forward, we are continuing to look at various different tree traits and the impact that they have on water storage by the urban canopy, as well as rainfall amplification. And again, boiling it down to how is this changing from one species to the next. And so this is some of the work that we're looking at. And the ultimate goal is to be able to build up our knowledge of different species and then understand how they work in various environments so that we can scale up and better predict which species will make the biggest contributions to this end goal of stormwater management by the canopy. We have 2 students in my lab who are doing research in this area, including Luis Rivera Cabero and Richard Rivera. And they've both been doing this work relatively long-term. Luis for the past 3 field seasons, and Richard began his work this build season. All right, so switching gears, we can take a lot of time, get into the weeds, if you will, of it all, looking at the relationship between urban trees and water. But from a research perspective, if this is your thing, you can, again, build a career on it. But if this is your thing and you make the claim that we're doing this to help urban foresters make more informed decisions about which trees should be planted to achieve these various ecosystem service goals, then I think it warrants doing work into understanding, but what type of guidance do urban foresters have now? And how does that guidance show up in their strategies for tree selection, management, what have you? And so thinking about that really motivated a second leg of the research that I've been engaged in since beginning here at MSU. And that is really looking at current urban forest management plans that are active here in Michigan. And we have a sister study that I have with a colleague in Maryland. But really diving deep into these plans via a method known as content analysis to understand what are these plans doing? Well, how are they actually addressing the use of urban tree cover to achieve urban stormwater management goals? And how comprehensively are they doing so? So like I mentioned, we've got this study going on with myself and my colleague, Marcus Hendricks, who is a professor of urban and regional planning at the University of Maryland. But we started the leg of the work in Michigan. And so I'll just show a few brief snippets of what we found so far. But we wanted to start off by asking a couple of questions. So number one, of all the communities in Michigan, how many actually have urban forest management plans? So we did the survey, found this number. We found 43 accessible plans. Now, what I'll share about accessibility for this particular project, that means we were able to either find them online through a Google search or to work with the Michigan Department of Natural Resources to identify them. Now, when we worked with the DNR and did our Google search, we found more than 43 documents, but they weren't all plans. Some were reports, many were ordinances, but a strategic plan, a management plan, we only found 43. Not bad, but obviously some room for improvement. Now, that's not all we were interested in. We also wanted to understand, okay, we got 43 plans, that's great. How many of them actually address using urban tree cover to reach stormwater management goals? So I know the answer, but I will throw the quick question to the audience. Anyone want to take a guess? 0, okay. Anybody more optimistic? 2, okay. Anybody else? 10, 5. Wow, we need some like optimism in this room. Listen, it was actually surprisingly higher than that. So 24. So 24 of our communities here, I'll show you the map, actually do address stormwater management or using urban tree cover to reach stormwater management goals in our great state of Michigan. That does beg a question though, right? So a couple questions, maybe more if you really, really care about this stuff, okay, me. So one of the questions that came up was, okay, this is cool. We've got what, 24 plans that include this. Is there any like decadal pattern or phenomenon that we can see? Do we see that more plans include this as time goes on? And okay, they include it, but to what extent? And so we'll take a couple minutes to just look at some of the answers we found to those questions so far. So first and foremost, this decadal trend, if you will. Our earliest plan was, I believe it was 1982. We had 2 in the 80s. One was 82 and the other was 89. The 89 plan, just for fun, drafted by an MSU student working under my predecessor, and that was in Saugatuck. But as you can see, over time, there has been a steady increase in the number of plans that actually address using urban tree cover to reach the stormwater management goal. On the flip side, and I think this is interesting, just proportionally speaking, we also see over the past 2 decades that there's a decrease in the number of plans that do not include this in their content. So I think that this provides us a glimpse into the fact that more communities are cognizant of the benefits that urban trees provide and are becoming all the more savvy or potentially strategic about incorporating that into their plans so that they can work towards meeting their stormwater management goals. So again, we see this time-based or time series analysis, if you will. of inclusion of this material in our plans. But that does beg the next question of, well, what does it mean include this material in the plans? And so that's asking that question really put us in a position to shape up this content analysis all the more and start going through and seeing some of the emerging trends in the plans. And these emerging trends led us to understand the key ways in which these plans do address using urban tree cover to reach these stormwater management goals. This is just a subset of the categories that we or the trends, if you will, that we began to see. But I think that these are the most interesting and drive the point home the most. So some of the categories that you'll see include some just general reference of stormwater management being one of the many services that urban trees provide. We also see that some of the plans take some time to actually go through and assign an economic value to the service of these urban trees providing stormwater management or stormwater mitigation. And then there are some plans that went as far as to very specifically call out the fact that we have had flooding issues in this community, and we are going to move forward with using trees as a sustainable solution to helping to mitigate these flooding issues. One of those communities was Ann Arbor, and the other was Flint. But as you go from the top to the bottom, you see that the more specific you get about understanding the relationship between trees, urban trees, I should say, and their impact on stormwater mitigation, the fewer and fewer communities will include that level of detail, which isn't a bad thing. It's awesome that we have over 20 communities that recognize and include text on it, these trees providing a benefit. But as we think about applying the knowledge that my research group is trying to produce, it puts us in a position to think about, as we begin to produce this information, how can we then work with municipal stakeholders to make sure that they understand it and then prioritize including it in their plans. So this is just a quick breakdown. I thought it might be interesting to share plan by plan, what level of inclusion, if you will, of material did these trees have with respect to outlining the relationship between trees and the provision of this stormwater management benefit. So most of our plans that are highlighted here, and again, there are other categories for which Iron Mountain did qualify, but most plans had some statement that trees provide a benefit of reducing stormwater. Fewer plans talked about the process by which that took place, but I was impressed to see that almost half of them did. And by that, they specifically included text that said, trees provide stormwater mitigation by providing interception via their canopies. So that language is out there. Makes you think about science communication, who's reading the plans, who's using them, and their understanding of these relationships. The year for the Flint plan, I think, was 2016, 2013 or 2016. I don't know if it was in response to the water crisis. Yeah. Other things that I think are interesting, and I just want to point out the distinction here, the interception estimates by urban tree cover. So a lot of these plans I will share are written by the same consultancy group. And so they provide this general language that 100,000 trees or such a certain number of trees will provide 100,000 gallons of interception, what have you. So that's what that is. And then the valuation of the local tree cover and the related benefit, again, fewer communities incorporated, but for those that do, it actually provides a phenomenal depiction of the service that the trees are providing, and a tool with which urban forest managers can continue to advocate for prioritizing this form of programming and natural resource management within their municipal boundaries, if you will. So the last thing I'll share from this particular project is what some of the numbers from some of the cities across the state. And so Detroit's plan, written in 2016, looked at, again, they ran an inventory. After running the inventory, looked at the relationship between canopy cover and stormwater mitigation benefits, and found that of all the publicly maintained trees in the city of Detroit, annually they are capable of intercepting about 271 million gallons of precipitation, and they valued that service at a little bit more than $2 million per year. Staying in Southeast Michigan, Novi, recent plan 2018, canopy cover or publicly maintained canopy cover in Novi provides almost 26 million gallons of interception, if you will, or interception capacity annually. And that's valued at a little bit more than 200K in stormwater management savings or cost savings. Heading up to the UP, which I was really honestly surprised and happy to see that a significant number of communities in the UP also did incorporate this language into their plans. We'll look at two communities up north, one being Marquette. So you might see the trend from Detroit to Novi to Marquette. The interception provided by the canopy is steadily decreasing, but still sizable. And there are related stormwater management costs, albeit they're lower here. And then not too far from Marquette and Ishpeming, again, lower volume ultimately intercepted annually, and the cost savings is relatively low compared to the other cities, but it's still worth noting that they incorporated that into their plan. And also for both Marquette and Ishpeming, they noted that the stormwater mitigation benefit provided by these urban trees was actually the biggest quantifiable benefit provided by trees relative to air quality improvement, an increase in aesthetic value of a neighborhood, and a few other categories. So beyond taking this and just being fascinated by the plans in Michigan, which I'll admit I also used to develop a background knowledge so that as I move forward in trying to build these partnerships, I have an idea of where the communities stand in terms of their prioritization of urban forest management planning. But moving beyond that, a few key things to take away from this part of the research. And one is that surprisingly, there is a notable proportion of plans statewide that acknowledge that stormwater mitigation is a benefit that urban trees can provide. That being said, there's still an indication, or there is an indication that there's still room for improvement and potential opportunities to partner with communities to help them build up their plans or establish plans first and foremost, as well as think strategically about how they can incorporate this understanding of the relationship between trees and stormwater mitigation within their plans if they so choose to do so. But on the flip side, when we look at communities like Marquette and Ishpeming, we see that yes, there is a quantifiable benefit that urban trees provide in terms of stormwater mitigation. You get a nice number, but the overall savings may be, for some municipal decision makers, it may be relatively low. And they may be of the mindset that it's just easier for us to build another sewer line, expand or update our gray infrastructure and go about our business. And so this is something that I think, being in the urban forestry community, oftentimes you get the tree huggers and you preach to the choir. And you have to remember that outside of the choir, there are still other municipal stakeholders that you need to work with and need to be able to communicate with and to understand, because there are arguments and points being made with validity from both ends. And so to that end, some of the work that I've also been involved in is working with, again, my colleague, Dr. Hendricks at the University of Maryland, about thinking about effective strategies for approaching the hybrid approach, if you will, to urban stormwater management, making sure that there's equal value placed on both green and gray infrastructure, and then communicating that with various stakeholders in various communities of practice. So Marcus and I have some work in review right now with the Journal of the American Water Resources Association that looks into that. But again, if we're thinking about building capacity, it's also important to be thinking about how do you get these messages to broader audiences. And so we've worked on publishing and sharing this work in Impact, which is a magazine that is distributed by the American Water Resources Association. And so getting that work out to, again, broader community of practice is something that is of top priority for me in the program that I'm building. But I also want to highlight that it's important to be building communities of practice. And as a land grant institution, that's part of what we're doing here at MSU, building up students. And so I'm going to take a few minutes just to transition into talking a little bit about the teaching work that I've done to help build up the next generation of urban forestry practitioners here in the state. I have the joy of co-teaching urban and community forestry with Dr. Burt Craig, and we do a lot of work in that class. We cover a lot, which obviously we won't have time to get into today, And some of it is the things that you would think we would cover, right? Tree risk assessment, tree valuation, ecosystem services provided by urban and community forests. But we also want to make sure that students coming through this class have an opportunity to develop those skills that they're going to need, not just to work with the trees, but to work with the people who are purchasing homes that have the trees on the property or that want that tree removed. How do you communicate? How do you engage with the community? These are things that we prioritize incorporating into that class. And so I'll just highlight 3 examples that we incorporate, one of which being community engagement. And you could probably guess that this photo was taken in the before times, but we had an opportunity to get out into Grand Rapids and plant trees as a part of the mayor's greening initiative in the city, which is well received or was well received by the students. And very much I'm looking forward to returning to this type of activity when it's safe to do so. But what we were able to do both before the pandemic, during, and hopefully moving forward is something that I created and very, I just really enjoy this project. But at the end of the semester, students are required to submit a film, if you will, for the annual Urban and Community Forestry Film Festival. They're short films. Film may even be a little bit dramatic, but just short communication pieces that allows them to effectively communicate with the general public about urban forestry. They have the free reign to create a 3 to 5 minute video on the topic of their choice. And there have been really memorable submissions over the past few years. If you're interested, a few of them are posted on the MSU Forestry website for your viewing pleasure. And there may be some folks who take the time to build effective careers in spoken science communication, but it's likely that wherever these students end up going, they're going to have to be writing and potentially writing to get money for support of their urban and community forestry programs. And so another staple of the class is this grant writing activity, where students are required to submit a mock proposal for the Michigan Urban and Community Forestry Grant Program. And again, students do this independently, but they've all had the opportunity to think about projects that could potentially be of impact, to think about what it would cost to actually bring that program to fruition, and to get their ideas on paper. And I can say that we've had some solid submissions through the years. That, like I said, is something that students might have to do on the job. And it's important to also remember that there will be people who want to go into this career field, but may not necessarily see a path through a traditional university setting, or may want to, but want to kind of test the waters at first. And so that makes us think about workforce development. What are the different ways that we can engage the next generation, if you will, of urban foresters, tree care industry professionals? And focusing on this question is really a part of that building capacity pillar and what I've invested in terms of building capacity over the past 3 years. And so I'll highlight a few of the workforce development programs that I've had an opportunity to be a part of before we wrap up today. So the first of these is Tree Work 101, getting started in arboriculture. And this was really a long time in the making, but rooted in a solid partnership that MSU Forestry has with ISA Michigan, formerly the Arboricultural Society of Michigan. And in our time developing this course and going through various iterations of ideas of what it might look like, we were able to join an additional partner in Muskegon Community College who hosted this program. And so again, this came out of really the demand from the tree care industry here in Michigan that identified that there's a need, right? We had a focus group in early 2019 with a couple dozen, if not more, tree care industry professionals come out and talk about if we had an opportunity to provide standardized training for entry-level employees in this industry, what would it look like? What would they look like after they came out of it? And what type of investment would an employer be willing to put into those employees in terms of providing support for them to go through it? Now, following that focus group, a survey went out to the larger community. We had more than 130 people respond, and the majority indicated that providing some form of standardized training would fix this gap that we have. That gap being that there are positions that are not being filled and likely not being filled because there's a lack of a trained workforce. And so the group consensus was if we can provide access to training, it's likely that we'll be able to fill these vacancies, increase productivity, and also ensure that there's a greater degree of safety with which this work is being done. Because as you all may know, tree work is invigorating, but it can also be very dangerous. And without proper training, people's lives are at risk. And so in order to achieve the goal of bringing this idea from an idea to an actual on the ground program, last year I was able to seek out and receive a grant from the Urban and Community Forestry Program operated by Michigan DNR with partners in Burt Craig and various colleagues from ISA Michigan. And we used this as seed money to run a pilot program. And this pilot program, again, it was hosted at Muskegon Community College for 5 weekends between April and May. And it was not easy getting up at 4:45 to be in Muskegon, but that drive was worth it. And I didn't have the farthest to come, right? We had students who were making the drive from Traverse City. We had students that were making the drive from Wayne, and then a few who were closer. But one thing I'll share that is not in the slides here is that we had 8 students in total, 6 of which were men, 2 were women. Several had not completed high school, but all were committed. Almost all showed up to every class. And these classes were not like come in at 9, leave at 12. They were full day classes. And for the participants that came from Traverse City, those who came from Grand Rapids, and our participant from Warren, which was 7/8 of the class, their participation was supported through their employers who paid for the cost of registration and mileage to and from, and for some actual hotel stay. So that confirmed some of the findings that we had from that focus group in that survey, that there's demand for this type of programming and employers who are willing to invest in it to ensure that they have a properly trained workforce. So we had a lot of different learning objectives that we tried to meet within that time frame. And I say we because this was a group effort. I served as director, but we brought in collaborators from across ISA Michigan, and we're able to provide instruction in climbing, chainsaw operations and maintenance, aerial lift and rescue, and proper felling techniques. And like I said, we were working in Muskegon, had the opportunity to work with Muskegon Community College and provided like real world training where we were removing trees at the golf course there to encourage more people to come out, because there was one tree, one hole overly shaded, always damp, and nobody wanted to golf there. So practical applications. Again, this was all made possible through collaborative efforts, a lot of in-kind donations from various partners across the state, to whom I owe a debt of gratitude. And just really quickly, beyond cool pictures and great stories, there were quantifiable impacts of this program across the board for every area of competency that we asked students to identify, how comfortable they felt with the material. Looking at their comfort and competency at the start of the course versus the end, we see that across the board, there was an increase in student competency in all of these areas. Outside of this program, there's another program that I've had an opportunity to develop and run in collaboration with colleagues here and at Tennessee State. And that program is Urban Wildfire. This was conceived pre-pandemic, and we didn't have a chance to run it the way that we wanted to, but that's okay because I think it turned it into something even better. But essentially with Urban Wildfire, this is a program designed to ultimately provide training in wild and fire management, but we're using the urban forest as that carrot, if you will, to sort of bring people in. And between myself and my colleague, Dr. Dietra Young at Tennessee State University, we provide training in urban and community forestry. Andy in our department teaches the wild and fire content. And then Dr. Tyler of the College of Ag and Natural Resources provides professional training in understanding how to apply and understand DEI principles in natural resources careers. So I'll take a few seconds to look at where our students came from and what we did this summer and where we're going moving forward. We had 11 participants from across the country and representation from 9 colleges and universities and students who represented a diverse racial, ethnic, and gender identity makeup. And this summer, we spent our time diving into iTree and providing students with the technical skills needed to actually know how to use 3 of the most popularly applied iTree tools. This was an idea that was graciously sort of developed with Beatra Wilson at the US Forest Service, supported through Phil Rodbell, and then facilitated with the help of additional partners who are split their time between Davie and the Forest Service. And essentially what the team came together with my team to do was visualize what this course might look like, how we can give students that training, and then what the long-term impact would be. And I'm happy to share that after seeing what we did for our students, the plan is to utilize this as a pilot for a iTree credentialing program that the Forest Service will offer. Moving forward, we're continuing to meet with our cohort this fall and spring, and we'll be continuing to provide training in other key content areas in urban forestry, including effective community engagement strategies. Other work I've done in community engagement and building up the workforce, we've developed an urban and community, or I should say an urban ecology pathway at University Prep Science and Math High School that was launched in 2019, fall of 2019. And the development continues, the modification continues. And this is through the gracious partnership of the school's STEM curriculum coordinator. And I have a current graduate student, Jasmine Brown, who's helping to continue to develop, develop our baseline understanding of how students are responding to this, and then how we can utilize that to make this curriculum all the more effective. There's also continuous work taking place with schools in Brooklyn and an urban forestry unit that we're building into the content that the Forest Carbon and Climate Program here offers. All right, so I'm looking at the time, thinking about the future and wrapping this up. So I just want to share briefly about some of the work that I'm looking forward to engaging in moving forward, some of which is supported. And there's 2 projects, one I can go into a little bit more detail with than the other, but both are supported through grants from the Great Lakes Restoration Initiative. One is currently on the ground now, and it's with in partnership with the Greening of Detroit and Friends of the St. Clair River in Port Huron. But essentially, we're looking at the use of gravel bed nurseries as a pathway to facilitating easier inclusion of various stakeholders and getting their hands dirty, getting some trees planted, and then ultimately utilizing those trees to work towards stormwater management goals. So this is a site that we have at the Myers Nursery in Detroit. And we have an upcoming project with some partners with the Forest Service and American Forest, who will be working with me to establish 6 site types across the city of Detroit. And on those 6 different site types, we'll have specific species that we'll be planting and determining the stormwater mitigation capacity of those different species and how it changes site to site. The ink is still drying on that contract, but we're set to start in the spring of 2022. And I'll wrap up by sharing that all this work, like I said, is made possible through partnerships, not just with collaborators in these various institutions, but also with the collaborations that we're building in my lab. I'm grateful for my current students with 2 PhD students, a master's student, and a bachelor student currently working in the lab. And also grateful for the work of students who have come and moved on to greener pastures, some of which are still here at MSU and other capacities, working in other capacities, and those who have gone on to bright careers in other locations. And I think with that, I'll stop and say thank you for your time and letting me share a little bit about my program, which, again, the intention is to utilize what's been shared today as a foundation to build on and continue these efforts moving forward. I will take any questions from Zoom or in the room. Dave and then Aki. Yeah. Mhm. 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 Good question. For the folks on Zoom, we had a question in the room, which was a two-part question. So the first was, well, I'll do the second first, it's fresh top of mind. But that question was, what type of impact might the bark chemistry have on some of the hydrochemical analyses that we're doing in the lab? And then what are the physical mechanisms that may be driving that in terms of bark interaction? Let me know if I missed any parts of that. In the rain itself. Yep. Yep. Good question. I will be honest and say that in my lab, we haven't done as much yet to look at how different components of the rain will impact what's interacting with the bark and how that may ultimately alter precipitation chemistry. But there is some work that has been done on that. And really it's looked at the relationship between acidic rainfall and leaching, specifically in conifer forests, conifer stands. I've not seen that work yet in an urban landscape. And I think that, that question does make me think about the potential to expand into that area in time. I think what I've done in the past has really looked at not so much the relationship between the precipitation chemistry and what's happening in terms of through-fall chemistry and stem-fall chemistry, but rather spatially speaking, if you're in an urban area, we tend to think of things as decreasing steadily along this urban to rural gradient, which is true. But within an urban area, you have so much variability with respect to land use. And those land use differences can ultimately relate to or be thought of as differences in emission sources. And that can have an impact on atmospheric deposition, what's being deposited and washes off. So I've looked at that, but I've not looked at the chemical composition of that rain and how that drives further chemical interactions, if you will, in the canopy. I think that's a potentially exciting research area. And just in terms of atmospheric deposition, well, leaching is real. Leaching is very important. But remember, like we said, with the enrichment ratio, it's not necessarily that you're seeing a higher concentration, you're seeing that concentration influence plus the flux influence. So it's like looking at the water, essentially all of what's being flushed down. The why behind that is interesting. The chemical composition of the bark is the root to that answer, but that's not what I've looked at so far in my research program. Aki first, and then Giorgio. Mm-hmm. Yeah, very good question. So the way that those numbers are based, or the way that those numbers are calculated, dates back to the initial establishment of the iTree program. So they looked at precipitation totals in various communities across the country. Then they've also looked at stormwater management costs in those cities. And based on what is known about precipitation yield, what it costs to treat stormwater for given yields, they use that information to then tie back into the estimates that they provide through the program. Does that get to your? Good question. Yep. So for those on Zoom, the question was, how does the iTree program actually calculate the benefits of that these trees provide, and thinking beyond stormwater mitigation, how are these other benefits also quantified and then assigned a value? And so in terms of what iTree is actually estimating when it looks at these stormwater management cost savings, they're looking at not so much, oh, if you get a rainfall of this magnitude, this is the type of damage that will be done to a street or what have you. But you do know if you're going to have a rainfall of a given magnitude in a city that has a certain amount of impervious cover, that you'll have this amount of runoff that's generated. When that amount of runoff is generated, it does have to pass through the city's or the region's stormwater management system, and there are costs associated with that. So whatever the cost is for treating that water before it's able to be released to an outfall is the cost that they use to calculate the savings in iTree. Other estimates that you can get from iTree are varied, and I may not get everything on the list, but again, you can quantify air quality improvement. And the way that they look at that is by getting baseline data from I believe it's National Atmospheric Deposition Program. So you get an idea of what's in the air. You get an idea of what that equates to in terms of harm to humans who will breathe it in. And then you link that to knowledge of canopy cover being able to sort of filter that out of the atmosphere, and that reduced amount being in the atmosphere, not being breathed into folks' lungs, and then the positive health outcomes of that. So many more, we could talk about it after. Georgios, and then a question or two that I have on Zoom. Good question. For those on Zoom, the question was asked, when we're looking at spatial variability and essentially enrichment ratios, is it that that's being driven by essentially differences in emissions from your urban center to your more or your less developed areas? Or is it possible that there are structural differences between the locations that may be driving those observations? And I think there's a lot of different ways. So my initial response is that it's likely driven dominantly by the differences in atmospheric emissions, if you will, deposition. There are ways that you can go beyond my initial, answer, and that is by looking at particulate matter or looking at sodium. When those pass through the canopy, it is clearly, those are things that are not necessarily being leached. And by studying those, you have an opportunity to determine whether or not what you're seeing is an effect of atmospheric deposition or structural characteristics of the canopy. I don't have data for that now, but one of the studies that one of my graduate students was looking at is looking at that particulate matter transit, if you will. And I think that that will help us to answer some of those questions. All right. 2 questions on Zoom, or maybe it's just one. So this one is from Emily, and she asked, thinking about the Tree Work 101 program, any thoughts on what the supply side situation looks like? Are prospective applicants not filling this job because of salary, interest, unaware this career exists, or similarly to the demand side perception? just simply don't have the skills. Could that be an interesting research project to supplement this work? I think yes to the research project. I think there's a lot of different factors at play. And I think whether or not people know about this as a career field, maybe based on where they are located geographically and their exposure, and exposure does change spatially. But I also think that there are efforts on the ground to change that. I think specifically about what American Forest is working on right now. And they have targeted projects in cities like Detroit, and I think others across the country, to actually introduce careers in the tree care industry to populations that haven't necessarily been engaged in this work. So it'll be interesting to see if those programs actually have an influence on increasing awareness, maybe even increasing diversity in the field. I think the other side of it is these careers are seasonal. That's not always of interest to folks who have families that they need to provide for year round. And then oftentimes they don't come with like legitimate, not salary, benefits that folks can depend on. And so I think lack of those things that will help a person feel grounded in a career can be a deterrent. On the flip side, like I said, for those who may not have a degree or formal training otherwise, there's easy pathways to employment through going through some of these entry-level tree care jobs. And so I think two potentially interesting studies are deterrence and then who's attracted to these jobs and why. And I think that can help shape future efforts to bring new folks into the fold. So.
All right, sweet. We have our hypotheses. Thanks for entertaining my not so subtle hint about doing another research project together.
I'm here for it.
Nice work, Asia.
Thank you. All right. Any final questions? All right. Thank you all again for your time today, and hope you have a good afternoon.